division and did some factoring. So now we're going to get back to some dividing. But today, oh man. Bro, I got a hole punch right there beside you. Hit a hole punch probably 10 or 15 at a time. All right, here we go. This is what we call synthetic division. It only works sometimes, but that sometimes that it works is the majority of when we use it. So, when does it work? It only works when you divide a polynomial by either x plus some number or x minus some number, okay? Notice x does not have any coefficient. It does not have any exponent on it. It just is simply x. So for instance, if I had x squared plus 3x minus 5 divided by x plus 1, I could use the shortcut on that because it's just x plus a number. Or if I was dividing it by x minus 3, I could use the shortcut. But if I had something like 3x plus 5, I would not use the shortcut for that. Not yet. I'm going to teach you how to use the shortcut using that method. You don't have to. He just asked me to further explain that. Now, the key to this is going to be placeholders. Before, you could kind of get by without having the placeholders. It would make it a little more confusing, but you could eventually get to the right answer without having placeholders. Here, you'll get the completely wrong answer if you don't do placeholders. How did you get your name on your bottle like that? Really? Oh, wow. That's cool. That's cool. I like it. All right. I think we'll jump into an example. It'll make it a little easier. Let's do imagine if you had to do long division on this. I would not either. So instead, we're going to use the shortcut, and I want to show you how much quicker it is. So let me run through. I'll show you how to do it. There's not really, it's hard for me to give you steps for this because it's pretty. So if you would do it There you go. Here's what we're going to do. We're going to take this number, but we're going to change the sign. So instead of -8, it's going to be a +8. We're going to do an upside down division sign with enough room for 2 rows of numbers in here. Okay? So you'll have a row of numbers here and a row of numbers here. Now the top row is going to be the coefficients of all of these, but you need to make sure you have placeholders if you need them. So I'm going to put with place. So in other words, all right, 5, 4, 3, 2, 1 constant. I don't need any placeholders. So on this first line, I'm just going to write 3, -26, 14, 18, -17, and 6. And I'll give you a second to catch up with me. That's a lot of stuff that you're not keeping. Hey, does everybody see where these numbers came from? All right. Here's the process. Take the first number and drop it down. And now we're going to start this process that's just going to continuously repeat. Other than the first step, everything keeps repeating. Take the number that's on the outside and multiply it to this value. What do you get? 24. That goes here, and we add. -2. Add. Yep. So we are going to constantly multiply, add until we're done. So always going back to this outside number, 8 times -2, -16, and add -2. Multiply -16 and add +2. Multiply and add and multiply and add. How in the world does this divide the problem? Now, while y'all copy that, let me come over to the side here, and I'm just going to work this long division quickly. You don't have to do this as well. I just want to show you because I want you to see how we interpret this answer, how much time this saves. If I do x minus 8, because some people will say, I just learned how to do long division. I'm just going to do it long division. And I'll say, okay, but it's going to be so long. So let's see, I need a 3x to the 4th. That gives me 3x to the 5th minus 24x to the 4th. It would be negative 2x to the 4th minus 2x cubed. Remembering how to do all this? Plus 16x. Is that right? What did I do? Oh, yeah. Never mind, because I got to subtract. Come back. Armando. What do I need up top now? X times what gives me negative 2x cubed? Negative 2x squared. Gives me 2x squared. Do you see how long this is taking me? Not that long. What do I need up top? 2x. 2x squared minus 16x. 1x plus 6. What do I need up top? Oops, that's negative. Negative 1. Leaves me with a remainder of negative 2 over x minus 8. All right. Look at my synthetic division and look at my long division. How can I use my synthetic division to give me the answer? Do you see the relationship? Do you see what's going on? What? Look at the numbers. Look at this row of numbers here that I got. 3, negative 2, negative 2, 2, negative 1, negative 2. What do you notice? It's all the same, okay? So here's what happens when I do synthetic division. This last column is always my remainder column. And then my next one is my constant, followed by my x squared. What do you think the next one is? X cubed. What about the next one? That's right. If I had more, I'd keep going. So what do I get when I divide these? Well, I would get 3x to the fourth minus 2x to the third minus 2x squared minus 2x minus 1. And then I always take that remainder and I put it over what I divided by. What do I have? Where? Change what? What are you talking about? I think you're seeing things. Thank you. What do you think about synthetic? It is a lot easier. Let's do another. Let's do one together. Now, it's really important that you come back and interpret your answer because you can't just leave it like this. You have to tell what it actually is. Y'all got that? What goes outside? First of all, can I do this with synthetic division? Yes, I can because it's x plus 9. What goes on the outside? Negative 9. What goes inside? Ooh, nice job. What? That was good. You're welcome. You gotta have that placeholder for the 2. Don't forget it or your answer will come out wrong. All right, drop it. Multiply, so you get negative 9. Add, 0. Multiply, 0. Add, multiply, add, multiply, add. Interpret your answer. 1x to the third plus 7 with a remainder, and you can do minus 2 over x plus 9, or you can do plus negative 2 over x plus 9, but either way would work. What do you think? It's good? It's good. Yes. I'm trying to decide. I need a stop shutting up. I had already run this sheet. I just ran it. Who said that? Yes, this is the one you did last week. If you still have it, take it out. If you don't, let's look at the ones we can do we can do synthetic for, and let's see if we can get the same answers that we did whenever we did long division, because these are quick. So number 1, yes or no for synthetic? Yes. How do you know? That's right. So what goes on the outside? -3. What goes inside? 1, 3, -1, -1, 6. Drop 1 down. Okay, multiply. -3. Add. Multiply. Add. Multiply. That better not have been your phone. Add. Multiply. Add. Ooh. No remainder. So what happens whenever I divide this? I get x to the third. Is that what you got when you did it? Because you just threw everything away. Oh, okay. Let's do one you didn't know. Well, we did it last week. We're just comparing. How about number 3? You can't do that? I don't know. Why not? Can we? I don't know. Look at what you're dividing by. Look at what's on the bottom. Number 3, not number 2. Sorry. Yeah, number 2 I can't do. But number 3 I could. Set it up. What goes outside? 2. What goes inside? 1. Nice. Drop down 1. 2. What in the world does that mean? A remainder of -4. So what happens when I divide this? Is it plus? There you go. See how much quicker this is already going than the long division? Just tell me yes or no. We won't work the rest of these. Just tell me yes or no. Could you use synthetic? Number 4. Yes. How about 5? 6? 7? 8? 9, 10. You actually can, that's why I hesitated, but I hadn't showed you yet, so we'll stick with 9. How about 11? 12. Would have cut your work in half if you'd known how to do this. Oh, it's a shortcut. I have pieces, because then you'd always try to do it.